ready now. Okay, so today I'm going to be working on problem 12.74. And the first part of this problem asks for how many zinc and selenium ions are in each unit cell of zinc selenide. So what they want you to do is actually refer to problem 12.72, which shows it shows zinc oxide, and the oxide itself has a face-centered cubic array. So what you're going to do is you're going to think that the selenium ions also have a face-centered cubic array. So what you're going to do at first is that you know it's face-centered, right? So you got to think for face-centered, each corner has 1/8 of an ion, and each face has 1/2 of an ion. And you use all the corners and all the faces. So what you're going to do to find the amount of ions is, so for selenium, the selenium ion, you think that, okay, there are 8 corners, and in each corner it's only 1/8 of an ion. So you first do 1/8 multiplied by 8 corners, right? 8 corner ions. And then you think, okay, there's 6 faces, and each face holds 1/2 of an ion. So then you add now 1/2 multiplied by the 6 face ions. Sorry. And then when you work out the math, you get 4 selenium ions. And now in the problem, they give you the chemical formula for zinc selenide. So what it is ZnSe. And because it is a 1-to-1 ratio, you can also assume that there's 4 zinc ions. Okay, so then for part B, they ask for what is the mass of the unit cell. So what you're going to do is you're going to think, how am I going to find the mass of this unit cell? And because it is an atom, you use atomic mass units instead of grams. So keep that in mind. So what you want to do is set up your equation here, which is mass of the unit cell. So I'll abbreviate unit cell with UC. And it's going to be 4 times the mass of the zinc atom. So I'll put M for mass, and then I'll put zinc here, plus 4 times the mass of the selenium ion. So then what you're going to do is you just look at your periodic table to get those values of zinc and selenium. So then now you just have 4 multiplied by 65.41 AMU plus 4 multiplied by 78.96 AMU. And you just add those together, and then you get 577.48 AMU. And you can look at this, and then you can look at the significant figures, and you can see that it adds up correctly. So this is going to be your answer for part B. All right? So then the next part they ask you to find is they want you to find the volume of the unit cell. I'm going to erase the first 2 parts so that I can have space to write part C. So what you want to do for part C is write out everything you know about the system. So they give you the density in the problem. So you know that your density, and that's a symbol, rho is a symbol for density, is 5.42 grams per centimeter cubed. And you know from your last part of the problem that the mass of the unit cell is going to be 577.48 AMU. So now we can look at this problem, and we see that there's actually a disconnect between the units. But we know that AMU can convert to grams. So what we're going to do is we know the conversion from AMU to gram. So the conversion is 1 AMU equals 1.66054 multiplied by 10 to the negative 24th grams per AMU. So now we have to think that we have to somehow get to a volume. And in this case, your volume is going to be in centimeters cubed. So what you want to start off with is you want to look at a way to get the centimeters on top. So what I'm going to do is I'm going to start off with essentially flipping the density so that I get centimeters cubed on top. So now you get 1 centimeter cubed over 5.42 grams. And now I want to cancel out the grams, right? So what I'm going to do is I know the conversion from grams to AMU. So I want to use this conversion right now so I can get to AMU and cancel it out eventually. So it's 1.66054 multiplied 10 to the negative 24 grams per 1 AMU. And we know the mass in AMU, so then we can write that in here. So then it's 577.48 AMU. And now we can look at all units, and you can see that they cancel out. And now we're left with the centimeters cubed on top, which is what we want. And that eventually equals 1.76924 multiplied by 10 to the negative 22nd centimeters cubed. But then we have to look at our significant figures, right? There's only 3 significant figures here, so we're limited by this amount. So the answer is actually 1.77 multiplied by 10 to the negative 22nd centimeters cubed. So this is your volume right here. So in part D, now they ask you, what is the edge length of the unit cell? And this is just going back to basic geometry. We know that a cube is just essentially the length. The volume of a cube is essentially the length cubed. So we know that for a cube, the volume equals L cubed. And what my L stands for is essentially the length of the side. And that's what we want to find. So we're going to isolate this L here. So we're going to just do the cube root on both sides, and then you get L equals the cube root of V. Now what you want to do is you want to essentially cube root the value you found here. And we're going to use a more exact number. We're going to use this number up here instead of this number because this number is a lot more exact for us. So now I'm just going to plug it in. And then now you get 5.6139 multiplied by 10 to the negative 8th centimeters. And you can see also my units eventually line up because I'm cube rooting centimeters cubed, which eventually gives me centimeters, which is a unit for length. So I know I'm going in the right direction here. And so now you look at significant figures, and because this answer had 3 significant figures, we have to do that for the length too. So the answer is really 5.61 multiplied by 10 to negative 8 centimeters, and that is your length value, and that is how you do question 12.74. That was it.